Okay, in this video I'm going to look at what's called special kinds of factoring. These are problems that are factored using a specific approach. So the first approach, or the biggest approach I'm going to look at in this video, is when we're talking about a difference of two squares. Now if you notice, we have these equations here that deal with squares and cubes. I wanted to show the cubes equation, not necessarily because it's something that we're going to talk about, but it is very similar to what we do with difference of squares. And when you're talking about difference or sum of cubes, that would be considered like your next step up. And you're going to approach them in a very similar way that we approach the difference of squares. Okay, so both of these are two very, I guess you could say, elite methods of special factoring. They require a very special set of circumstances in order to occur, and those circumstances happen to be that when you're talking about a difference of squares, what you're factoring looks like x squared minus y squared. When we're talking about cubes, it's going to be the same thing. Your circumstance would be the difference of two cubes or the sum of two cubes. Okay. And then obviously when you factor them, they will always factor into this part. So what we're going to look at is how do we go from my equation or expression down into its factored pieces. Now, there's a couple things that have to be kept in mind when working with a difference of two squares. First is you have to remember that a difference of two squares will always factor into a plus and minus form. Also, a difference of two squares, a lot of times you may have to factor more than once. So you're really going to have to look at, once you factor down into its pieces, can you go any further than where you went? The steps to use are fairly simple. First and foremost, you always want to look to see if there's a GCF, that greatest common factor. The second thing you want to do is you always want to make sure that your terms are subtraction. In other words, if this up here said x squared plus y squared, you cannot use this method. What we're looking at specifically is that subtraction term. You're going to look at each term individually in terms of its square properties, and you're going to reduce them down. Once you do that, you need to create your factors. Okay, so let's go ahead and take a look at that. So I have y squared minus 121. So first and foremost, you need to remember your formula. So the formula says x squared minus y squared is the same as x minus y times x plus y. So that is what we're doing. So what we have to determine is we have to determine what is this x value and what is this y value. So I have y squared minus 121. So what that means is that this first value is your x, and this second value here would be the y side. And notice I do have my subtraction, so I can use the method. So here what I actually have is I have that my x term is going to be represented by y, and then my y term is going to be represented by the square root of 121. So if we take the square root of 121, we get 11. So now what we have to do is we have to take this y and plug it in for the x, and then we take this 11 and plug this in for my y. So what I have here is I have y squared minus 11 squared. So because of that, I can actually write my equations out. So this is going to be the same thing as saying y minus 11 times y plus 11. And that's all we need. This right here would be my factored form. Alright, let's look at another one. So here, down here, I have 5x to the fourth. So I've got a 5x to the fourth minus 125. So the first thing that we need to do is we need to identify a GCF. So I have a greatest common factor, and in this case it would be 5. So I need to pull that out. If I pull out the 5, I'm going to leave behind x to the fourth minus 25. This 5 is going to be along for the ride, but I now have two separate terms. So again, if we look at it, this first term here is going to represent the x value, and this second term here is going to represent the y value. So just like before, if I look at it, in order to find my x value, I have to take the square root of x to the fourth. Well, when we break down x to the fourth, we know x to the fourth can break down into x squared and x squared. So what this tells me is that I have x squared as my first part. And then if I break down my y, or look for my y, I have to do the square root of 25, which in this case is going to become 5. So I have 5 times x squared squared minus 5 squared. This is what I have. So again, if I take a look at it, this is going to represent my x term. This is going to represent that y term. Using the formula I know, this is going to become 5 times x squared minus 5 times x squared plus 5. Now, in taking a look, notice I have another square term because x squared is a perfect square. I have a subtraction, but notice if I look at 5, it is not perfect. Since 5 is not a perfect square, there is nothing more to do, and thus these are my factors. Alright, let's take a look at another one. So here I've got 4x squared minus 49. Notice I don't have any GCFs there. So what I have to look at is I have to look at each individual. So what I need here is I need to turn this into something squared minus something squared. That's my goal. So I have 4x squared. If you look at this, notice 4 is a perfect square and x squared is also a perfect square. So if I reduce this down, 4 reduces down and becomes a 2. And take the square root of x squared and you get an x. So again, the math that I did here is I took the square root of this term and ended up with 2x. So this 2x is what goes here into this parentheses, this first part. So I have 2x squared. Now I need to fill in the rest. So this says I have to take the square root of 49. When I take the square root of 49, this is going to give me 7. So again, just like before, this 7 here now is going to fit into the second part. So this is going to say minus 7 squared. When you look at them, this first part here is going to be my x, and the second part here is going to be my y. And taking that into consideration, all that we have to do is just simply plug it into your formula. So again, that formula says that we are going to do x minus y times x plus y. So here, this is going to be 2x minus 7 times 2x plus 7. And that would be everything I needed. And here are my factors. Now to check myself, I could simply multiply this together and you should get what you started with. Okay. Alright, let's break down another one. So here I have 50x cubed minus 8. So in looking at this, the first thing that we need to do is we need to identify a GCF. Okay, so here my GCF is going to be 2x. So if I pull that 2x out, I have to look at what's left behind. 50 divided by 2 is going to be my 25. Pull an x out and gives me x squared. 8 divided by 2 gives me a 4. Pull an x out, takes it out completely. Now, if you look, you can see clearly that this first part is perfect square and the second part is a perfect square. So here, this is going to reduce down and become a 5x. And this is going to reduce down and become a 2. Again, this is going to be the x term, and this one is your y term. So if you go back to your formula again, we're going to have 2x, and then we're going to have 5x minus 2 and a 5x plus 2. Okay. Now for grins, let's just simply do a couple more. Notice here I have y squared plus 100. Pay very close attention. My sign or my operation here is addition. This is not a difference of squares. This is not factorable. So when you're looking at these, you need to pay very close attention to the operation that you have. If you have two terms and your operation is addition and your operations are square, they're not factorable. And the reason for that is because, take a look at the equation. The equation we're supposed to use is that x squared minus y squared is the same as x minus y times x plus y. Okay, and so the reason for this is because that middle term is going to cancel out. If we were to multiply this together, you'd get x squared. Here would be xy, this would be negative xy, and then you'd have minus y squared. So your middle terms there would totally cancel out. Now the argument I hear students make is they say, well, wait a second, instead of this being just simply x minus and x minus, doesn't you change this one to plus? Well, the answer is no, because again, if you FOIL that back out, your middle term would still be there, and in this case, it's gone. Therefore, this is actually a not factorable form. Now, the last one I wanted to look at was this bottom one, specifically because my last term is a 1. A lot of students here will say that this is a non-factorable expression, and in this instance, you would not be correct. Now, whereas there is no GCF here, we have 81x to the 4th minus 1. So if we take a look at it, 81x to the 4th, if you take the square root, this can actually become 9x squared. Take the square root of 1. When you take the square root of 1, you get 1. So this stays the same. It's still going to be the 1. So what we actually have here is we have 9x squared squared minus 1 squared. This is representative of the x term. This is representative of the y term. So my actual equation comes out to be 9x squared minus 1 times a 9x squared plus 1. Now this back term, there's nothing we can do about it. But take a look at this first term. I have a 9x squared. What do we know about it? Well, we know 9x squared can actually become 3x. We also know take the square root of 1 and we still get a 1. So this term here factors again. And what happens is this term is going to end up becoming 3x minus 1 times 3x plus 1, and then times the 9x squared plus 1. So this is a classic example of what I meant when we said in the beginning that sometimes you have to factor your term more than once. So you have to pay very close attention to what happens once you get your term. Is it still a difference of squares? So that's everything you need to know about the difference of squares and how to work with them and how to factor them. If you have any questions, please let me know. Otherwise, I hope you enjoyed, and I'll see you next time.